So this exercise is related to chemical energetics, energy from the chemicals. Some of the questions we already solved. Now, hydrogen decompose as shown. The change in energy is minus 95. So they give us the change in energy. We need the energy for nitrogen-nitrogen bond. So how we can work out this, how we can find the bond energy, it's the same way as we know whenever a chemical reaction occurs, the reactant side is a bond breaking side and the product side is a bond forming. And bond breaking minus the bond forming is equals to energy change. If a reaction is exothermic, energy change will be negative. If the reaction is endothermic, the reaction energy change will be positive. So bond breaking minus bond forming is always equal to energy change. So what about the bond breaking energy? That I am writing on the left hand side. The bonds which we are breaking NH bonds. But how many of them we are breaking? 1, 2, 3 and 4. So there are 4 NH bonds. Plus we are breaking nitrogen-nitrogen bond. That is bond breaking. So 4 NH bonds are there. Each NH bond having an energy of 391. So it will be 4 into 391 plus nitrogen-nitrogen bond, that is we are finding, we don't know, so we can say this as X. You can even write NN or you can also write X. X means unknown. So it will be 391 multiplied by 4, that's equal to 1564. So 1564 plus X. That is a bond breaking. What about bond forming? Nitrogen triple bonded with nitrogen. This is one of the bond form, and there are 2 hydrogen-hydrogen bonds. So nitrogen triple bonded with nitrogen is 945 plus 2, and hydrogen-hydrogen single bond, that is 436. So 436 multiplied by 2, that is 872 plus 945, that is 1817. 1817, that's a bond forming. So we have bond breaking, we have bond forming, and according to a formula, that bond breaking minus bond forming is equals to energy change. So bond breaking energy, which is 1564 plus X, that's a bond breaking, minus bond forming, it is 1817, and that is equals to energy change. So they mention in the question the change in energy is minus 95. What is the meaning of minus? A negative energy change, it means the reaction is exothermic. If the reaction was endothermic, then energy change will be positive. So here the energy change is minus 95. Now we simplify, we solve this equation like in mathematics you used to solve. I will write it on the left hand side because of space. So 1564 plus X minus 1817 is equals to minus 95. That is our equation. So it is 1564 minus 1817. So this will give us minus, when we solve these two numbers, we'll get minus 253, and that is minus 95. This is minus 253, it is subtracted, so when it moves to other side, it will be added. So X is equals to minus 95 plus 253. So minus 95 plus 253, that will give us the value of the x will be equal to 158. So that's why A will be the right answer. Is it clear discussion that how we work out the energy of the bond? So first we got the bond breaking energy, then we got the bond forming energy. But in the bond breaking energy, one of the bond energy we don't know. That's why we write that as X. And bond breaking minus bond forming is equals to energy change. So bond breaking was 1564 plus X. Bond forming is 1817. And the energy change is given minus 95, which shows that this reaction is exothermic. So when we substitute the values and find the value of unknown, which is X, we'll get as 158. That's why A is the right answer. Is it clear this question? Anyone having a doubt this part? Any question or doubt in this one? Okay, another question. So some properties of four fuels are shown. There are four fuels. Hydrogen is there, methane is there, octane is there, and wax. The question is, which fuel is a gas at room temperature and makes two products when we burn? So first, remember when we have the melting point and boiling point, the state of the substance between the melting and the boiling point, that will be liquid. State of the substance after the boiling point will be gas. And state of the substance before the melting point, it will be solid. So when we check the state at room temperature, so room temperature is 25. So when we check where 25 will come for hydrogen, it is minus 259 and minus 253. So 25 will be here, hydrogen will be gas. For methane, where 25 will come again after boiling point, so methane will also be a gas. About octane, 25 will come between melting and the boiling point because minus 57 and 126. So it will be a liquid. And here 25 will come before the melting point, so it will be solid. So basically C and D cannot be an answer because we want a fuel which is gas. That's first thing. And the second thing, it has, when we burn it produce two products should be there. So if we burn hydrogen, when we burn hydrogen, hydrogen burned in the presence of oxygen, it can only produce water. But when methane is there, CH4, when we burn in the presence of oxygen, it produces carbon dioxide and water because it contains carbon and hydrogen. So that is why for this one, B is the right answer. Is it clear discussion that how we work out that which reaction or which fuel is gas? So how to work out which fuel is a gas? So we'll find the temperature, the room temperature should be more than the boiling point, so the substance will be gas. And the second thing they ask, it should give two products when we burn. So hydrogen give only one product because when hydrogen mixed with oxygen, it gives water. Whereas methane, when we burn methane CH4, it gives carbon dioxide and water. So when we compare, because in the question they're asking two things, which fuel is a gas and which makes two products. So which one is a gas? When we check, because room temperature is 25, so 25 for hydrogen will be after the boiling point. For methane, it is after the boiling point. For octane, it is between the melting and the boiling point. And for wax, it is before the melting. So it means octane will be liquid and wax will be solid, so they cannot be an answer. We are left with hydrogen and methane. So if we burn hydrogen, combustion or burning of hydrogen means hydrogen react with oxygen. So it only give one product, that is H2O or water. But when we burn methane, which is CH4, what it give? It give carbon dioxide because carbon react with oxygen, and it give water because hydrogen react with oxygen as well. So there are two products in burning methane compared to one product when we burn hydrogen. That is why it contains carbon and hydrogen. So when carbon is burned, it produces carbon dioxide, and when hydrogen is burned, it produces water. So because methane, which is CH4, contain carbon and hydrogen, so combustion will produce water and carbon dioxide. Another question, question 6. Which statement about exothermic and endothermic reactions are correct? Exothermic reaction, heat energy is given out. That's correct. The temperature of endothermic reaction goes up. The temperature does not goes up. The temperature, because the mean temperature of the, not the substance, they're talking about the temperature of the solution. So if you have a solution and or a water and there are particles inside the water which are reacting. So if initially the water is at temperature of 20 degrees and the reaction is endothermic. So if the reaction is endothermic, the particle will take energy. But from where the particle take energy? The particle take energy from water. So when the particles take energy from the water temperature will decrease. So the temperature of endothermic reaction not goes up, that is wrong. It should goes down because the particle take in heat energy from the water or the liquid. That's why the temperature should go down. And burning methane, that is CH4, is whenever you burn anything, the combustion reactions are always exothermic. That's why C is the right answer. Is it clear, this question? Another question, the energy change we already calculated in the last part. In the question, heat energy is produced when hydrocarbons are burned. Hydrocarbon means the compound which contain carbon and hydrogen. Which equation represent this statement? The term hydrocarbon means the compound which contain carbon and hydrogen only. That is the meaning of hydrocarbon. So here we are burning C2H5OH. Is it hydrocarbon? Yes or no? C2H5OH. Is it hydrocarbon? It is not an hydrocarbon because the term hydrocarbon means it contains carbon and hydrogen only. But when you check C2H5OH, it's not an hydrocarbon because the oxygen is also present. So one is not a hydrocarbon. What about second one, C2H4? Is it a hydrocarbon? The second one is a hydrocarbon because it contains carbon and hydrogen. And the third one also is a hydrocarbon. It contains carbon and hydrogen. So D is the right answer because they're saying heat energy is produced when hydrocarbon burn. So when we burn hydrocarbon, means the compound which contains carbon and hydrogen only, that produces heat. So the correct answer is D. In this question, hydrogen and chlorine react to form hydrogen chloride and the reaction is exothermic. Exothermic reaction means it releases energy or energy change will be negative. H2 plus Cl2 gives 2HCl and the energy change is minus 184. What is the energy for CCA chlorine bond? So H2 means hydrogen hydrogen, Cl2 means two chlorine atom bonded, and 2HCl means two molecules of HCl are there. So reactant side is a bond breaking. The product side is a bond forming. So the bond breaking minus the bond forming is energy change. The bond breaking hydrogen hydrogen bond breaking is 436 plus chlorine chlorine bond we don't know, so we say that as X, like this bond energy is X, and the bond forming, that is 2 multiplied by HCl bond, that is 430. So this is 436 plus X and this is 860. Now we know the bond breaking minus the bond forming is equals to energy change. So the bond breaking minus the bond forming is energy change. So what is the bond breaking energy? 436 plus X, that is the bond breaking, minus the bond forming, that is 860, equal to energy change in the question. And keep in mind, if the reaction is exo, the energy change must be negative. So it is minus 184. As they mentioned, it is exothermic. Now when we solve for X, so it is 436 plus X minus 860 is equals to minus 184. So when we solve 436 minus 860, it is minus 424. So X is equals X minus 424 is equals to minus 184. This is minus, other side it is subtracted, other side it will be added. So X will be equal to minus 184 plus 424. So that will give us the value of X will be equal to 240. So the bond energy for Cl, the X is 240. That's why D is the right answer. Is it clear, this example, how we work out the bond energy? Any question or a doubt in this part? So always the bond breaking minus bond forming will give us the energy change. When anhydrous copper sulfate was added, which row shows the temperature change and type of reaction? So when we add, they mention heat is given out. So when we add this copper sulfate will give out heat energy. So when this copper sulfate give out the heat energy, the water will absorb that energy. So if the water absorb energy, the temperature of the water increase or decrease, the level of the mercury in the thermometer, it will, the level of the mercury in the thermometer, it will rise because the temperature increase, and this reaction is exothermic. Because the heat is given out as they mentioned, so whenever a heat is given out, the reaction is always exothermic. Is it clear this example? The question? Is it clear, this example? That because the reaction is exothermic, so when the reaction is exothermic, it will release the energy, and when it releases the energy, the temperature will increase. The energy level diagram is there. So if energy level diagram, so first thing, reactant have low energy, product is having high energy. What we call that this is the energy diagram for endothermic reaction. Which statement is not correct for this energy diagram? It could be energy level diagram for reaction between petrol, when petrol is burned. So when petrol is burned, it means the exothermic. So they're saying it could be energy level diagram for exothermic. It is not for exothermic, it is endothermic. So A is not the right statement. In the question they're asking which statement is not correct or not true. So the first statement they mentioned, it could be energy level diagram when we burn petrol. So when we burn petrol, combustion or burning of the petrol is exothermic. But this energy level diagram is not for exo, it is for endo. So that's why A cannot be the right statement. Why B is the right statement? The less energy is released when bond forming, because it's a endothermic reaction. Endothermic reaction, bond breaking energy is more than bond forming. That is true. The activation energy is positive. That's also true. And the energy change, the difference in the energy of reactant product is also positive. So if it's activation energy is always positive. It does not depend on whether reaction in the endo or exo. But energy change for endothermic reaction it is positive, and for exothermic reaction it will be negative. Which experiment is the most exothermic? Initial temperature 20, final is 5. So first A cannot be an answer. Why? Because A is endothermic reaction. 20 change to 32, so 12 degree change in temperature. 25 change to 12, so that cannot be because it's also endo. 25 change to 34, that is exothermic but 9 degree. So which one show a greater change in the temperature? Not the highest temperature, the change in the temperature. For experiment B, 20 change to 32. So it is a 12 degree change in temperature. But for experiment D, 25 change to 34, it's only 9 degree. So the correct answer is B. Because the one which show a greater change in temperature, it means that is the most exothermic. And question, the energy level diagram is there, and this is energy level diagram for exothermic reaction because the reactant have more and the product is having less. So either A can be answer or D can be an answer. Energy change for exothermic reactions is always negative. And what about the sign of activation energy? The sign activation energy is always positive. It can never be negative. So activation energy is positive. So D will be the right answer. So this was exercise related to topic chemical energetics. We are done with this topic. I will share these exercises with you.